Okay, welcome back to day one of polygons. We've been talking about interior angles of the polygons, the angles that are inside, but now we're going to talk about the angles that are outside the polygon. I mean, you might not have really thought about that before. Hey, there's angles outside the polygon. So there's some very cool things that happen with the angles outside the polygon. Let's just read through this first little paragraph and then I'll explain it to you. It says, let me get a pen, an exterior, it might be a little hard to fit that in there, exterior angle of a polygon is formed by extending. That means we're going to make it longer. We're going to extend a side of the polygon into a ray. And we want, let's see, to be the sum of the measures. Okay. So I'm not sure we're going to do this. This doesn't make sense. Sorry, I should have proofread that a little bit better. Now there's going to be some interesting stuff. You're going to like how this works out. So let me show you a picture. Now those are exterior angles in red. You probably don't see them in red in your packet because your packet was printed on the photocopier. However, in red, you can see how those little dotted lines were made from taking a side and making it longer. Okay, so let me show you what I mean. I'm going to show you a blank slide. This is not in your packet. I'm just going to take a triangle and I'm going to show you how they did that. Like if I were to come along a side, okay, that's the side, but if I were to keep on going, that would be the exterior angle. Now, where is that exterior angle? I mean, we keep calling it exterior, but what does it really look like? This is what it really looks like. That's what the angle really looks like. So the vertex of that angle is right here. And in this particular drawing, that angle looks obtuse. It looks like it's bigger than 90, but that doesn't mean that all exterior angles are going to be that way. I just drew a very simple example. If you go back and you look here, we have at the bottom of page 4, we have that 1, 2, 3, 4, looks like a hexagon, 6 sides. And so we're going to have 6 exterior angles. Okay. Now, if it's a regular polygon where all of the inside angles are the same, then all of the outside angles are also going to be the same. So that's kind of an interesting phenomena that we have. We have right here inside, we have an interior angle, and then we have an exterior angle. Very interesting to me how those relate to one another. So now if I were to do this, and I'm going to keep my highlighter, I'm going to draw us a little shape. Those exterior angles can be formed into a circular shape. And that's the interesting part about it. The sum of the exterior angles is 360, just like a circle. So that's kind of cool. I like that concept. Okay. Now, this is one other thing I want to show you. Exterior angles and interior angles are supplementary and form a linear pair. So let's go back to my triangle picture. Let's say that this was 60 inside. Well, what's happening here is this exterior angle and this interior angle are forming a linear pair like that. And we know that this one is going to be 120 because linear pairs always add up to 180. So if we know an interior angle, we know the corresponding exterior angle by subtracting it from 180, which is kind of cool. That's a very nice relationship. So We typically fill out this chart very, very quickly because there is no formula for exterior angles. Like the n-2 times 180, it doesn't matter how big your polygon is. The sum of the exterior angles is always, for any shape, going to be 360. Always. Now, if we have a regular, we're just going to divide that by 3. 3 sides. We want one of them. That'll be 120. Divided by 4, that's 90. I might have to get the calculator out here in a minute. I think that's going to be, I'm going to double check because I don't trust my mental math. That's going to be 72. 360 divided by 6, I know, is 60. And the 7 is going to be a decimal. But remember, we got a decimal on the other one when we did the interior. So we'll call that 51.4. And so if we want a regular polygon, all we have to do is divide by n to get one exterior angle. Now, what I want to show you is if we go back to that chart on page, I think it's page 2, and we were to pull the interior angle, the 60, the 90, the 108, I'm going to go fill that in. So the interior angle was 60 and 90 and 108. Hang on, I got to go back and get the other 2 numbers for the 6 and the 7. 120 and 128.6. Okay. I just want to show you something here. So these are my exterior angles. Let me highlight. These are my interior angles. Now these happen to be in a regular polygon, but it's true for any polygon. What's going to happen here? If we were to take these and add them together, and of course this last one would be n-2 times 180 divided by n, we would get 120 plus 60 is 180. That's the exterior plus the interior. We would get 90 plus 90, 72 plus 108, 60 plus 120. See what's happening here? These are all supplementary, just like we said on the previous page. So that's a nice thing to know. I've seen that before pop up on an SOL question. So let's take a look at a couple of problems. Now these look like crazy messes, but they're all exterior angles. So what we're going to do is we're going to say, okay, first of all, these are exterior. We know that they add up to 360. And so we're going to go ahead and set up an equation, and I'm probably not going to be able to get this onto one line just because it's kind of long. And remember, Desmos will wrap it, so you won't be able to see all of it at one time. So that's what it's going to look like. It's going to be part plus part plus part plus part, and that's how we're going to put it into the Desmos. But it's always going to be equal to 360 if it's an exterior angle. So watch how that works. So we'll have a 46. We'll have a 3x. Have a 62. 4x. 47 plus 93 equals 360. Now, chances are I'm going to have to zoom out. Yeah, there we go. So I get x is 16. It said write an equation and solve for x. And we did that. So we're going to do that again over here on the right. These are exterior angles. So I'm going to put here equals 360, but I'm probably going to have to loop it around a little bit because it is kind of a long equation. I'm going to start right here with this guy. That angle is so small they couldn't even put the x inside. They had to draw an arrow to show you that that was x. See how I'm just walking around the triangle and adding, or polygon, sorry, it's not triangles anymore, and I'm adding up all of the parts. I'm taking a little picture of it so that when I go over to Desmos, I can enter all that stuff without making a mistake. So we'll have the x plus the 54 plus the 45 plus the 50 plus the 42 plus the 4x plus the 8x. It looks like x is 13 for those. So really the process here didn't change for exterior angles. It just got simpler. We didn't have to do the n minus 2 times 180. We just had to set up all of the parts, adding up all the parts, and equal to the whole, just like we've been doing since the beginning of the school year when we had parts and a whole. Okay, so then here, if we turn to page, let's see, what page is this? Is this 5 or 6? Page 6 at the top. They're going to tell us one, it says but this is only one exterior angle in a regular polygon. We're going to solve for the number of sides. Well, remember, if we go back to our chart on the previous page, if we have 1, that's equal to 360 over n. So I'm going to set each of these equal to 360 over n. Now you can solve these really easily by cross multiplying. Let's try to put one into the Desmos calculator. I have a feeling it's going to have a little bit of an issue with the variable being in the denominator, but we might be able to see it enough to be able to tell what it is. And I'm going to make this x because it's Desmos. Here I think you can see, and these are usually going to be whole numbers because they want the number of sides. So I think you can see if this is 0 and this is 5, that this is 1, 2, 3, n is 3. So it's still going to work. It's just not going to, when you click on that intersection with the x-axis, it's not going to give you the actual ordered pair. So let's try 22.5. Let's change this one. I messed something up there. There we go. We're still getting an answer. If you look over here, this is 15, then this is 16. So n is 16. I think you can still read it off without having to cross multiply. Oh, I think I just typed, I think I typed this one in. I'm so sorry. This should be n equals 3. I typed in 120 on that problem. Hope you noticed my mistake there. So let's do 20 now. Let's go back to that first problem. And this one is going to be 15, 16, 17, 18. So sorry. So I think I just got those out of order. I think when I typed in that first problem, I put a 1 on the front of it. So that's how you do those. They're not that hard. You are going to need your packet in this unit because there are enough formulas and different things that you are going to absolutely want to be able to refer back to this. Okay. So please, 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 if you have not picked up a packet and you really now, like if you didn't pick up a packet and you're deciding, hey, this will be a really good time to get a packet, you can still contact me or Miss Valverde and we can arrange to get one to you and we can set up a time to meet. Okay. Alrighty. Thank you very much for watching.